All right, hey, what's up, guys? Mr. Fortin here. Hopefully, you watched the lesson on section 5.4 and you learned about the AA similarity postulate. Now, I filmed this other video. I filmed this before I actually filmed the lesson. And I was like, I just got to do the lesson on this. But I used this lesson to use a compass, okay, a compass and a straight edge to copy. I got this triangle right here. Check it out. I got this pink triangle right here. If I copy two angles of this triangle, right, I'm going to copy this angle here and I'm going to copy this angle here. And here you see me getting going right away. I might pause this for a second. I'll let it fly. If I copy those two angles to a different place on my sheet of paper, and I can adjust the sizes of the sides, right? Adjust the size. But if I copy those angles, angle 1, angle 2, over to different places, and I try to form a triangle, I'm going to get a similar triangle. So I'm going to get the same shape, but it might be a different size. So I'm showing you just two angles and gets you there, okay? So I might pause for a second and just maybe explain what I did here because you're not using compasses and straight edges this year. And this is something that's been used for thousands of years. Euclid used these when he first kind of came up with the geometry we're studying right now 2,300 years ago. And compasses have been used throughout the years. Leonardo da Vinci invented a new compass called a parabolic a compass here. So this has been a main way that people have actually been able to draw figures over the last few thousands of years and prove things about figures. Okay, so just real quick here, what I've done so far is I started. This is my given triangle. I'm trying to show you that if I just copy that angle and that angle here, and I'm going to do that right here. Angle 1, I'll move over here. I'll move angle 2 over here. I made a mistake and showed some marks here, but I'll move my angle 2 over here. So my second triangle is going to be much bigger. I'm going to do a much smaller one down here, but same principle is going to stay in place right here. I'm going to copy angle 1 and angle 2 and just show you if I copy those two angles and I have a couple lines, the rays, the sides of the angles that we don't see yet, right? They share, angle 1, angle 2 share sides here, but then we have this side and this side here. When those two sides converge in my other triangles, it might be bigger triangles, but they're going to be the same shape, different size. There's going to be some sort of scale factor or something like that. They're going to be similar, right? Because it only takes two angles of one triangle. If we find another triangle that has two congruent angles to those original two angles of the triangle here, those triangles are going to be similar. And this is a posture, right? This is an assumption. So just to show you, like, this is an assumption we're making, you could reproduce this. You could test this on your own. And if you're copying those two angles, you're always going to get similar triangles. So I know that I showed you that one example of the moving around computer thing, but I wanted to show you this compass thing just to give you more examples, right? To show that, just don't take my word from one example. I'm going to show you a whole bunch of examples, and we're just going to get similar triangles. So we'll check it out here, okay? So there we go. I already copied one angle. Maybe I'll explain what I did there. And, we won't be constructing stuff this year. So basically what I did to copy an angle here, I want to copy angle 1, and I wanted to use this point as my vertex. So what I've actually done here is I've taken this compass, and I've set it to any distance whatsoever, but I've dropped this compass right here with the center on it, and then I've swung an arc, okay, swung an arc. So that means that length here, from that point to where the end of the arc is, this point to the end of the arc is, that's congruence, right, congruence. Congruent here, congruent here. That means that I know that from this point here to here is going to be congruent to that segment. From this point to any other segment along here is going to be the same distance as that segment. So in order to actually copy an angle, you create congruent triangles. Check it out here. So now I reset the compass, put the compass, center it at sort of below here, and then copy another distance, and I'm kind of going fast, but this distance here was from another arc, like spin of the arc, okay, from earlier when I had done this over here, right? I had actually set the distance here. So basically, right, I have this segment's congruent to that segment because it goes to this swing of the arc, and remember, a swing of an arc, like of a circle, right? This is the radius, and this is the outer ends of the radius, and that distance remains constant, remains fixed with a compass. That's what a compass does, helps you maintain a fixed distance, okay? So that is congruent to that, that's congruent there, and if I set this to a new distance, right, this would be a third distance, or actually a second distance here, but a third side. If I copy that over, which I did in here, right, look, I'm copying that distance and I'm gonna copy it over there. If I draw a line right now, I would know, right? Because you don't see it here. I didn't actually do it. But if I drew that and that, I'd have congruent triangles. So anyways, congruent triangles, corresponding parts of congruent triangles, angles would be congruent here too. So that's how I copied an angle. Maybe you're not seeing how I did that. It's fine, right? We're not going to have to worry about this year. We're not going to have to do with these little two things here, okay? But I got a straight edge. Remember, lines are straight, sides of triangles are straight. So, right, copy where the angle should be and then put it through, okay? Put it through. Okay, so I just copied the other one, and look at that. How about that? Check that out, okay? So another inductively, Just seems to work out here, okay? So if we have the only two givens, the only thing given to you in this situation was that angle 1 and angle 2 are congruent to angle 3 and angle 4 respectively right there, okay? So I copied two angles, I wound up with two similar triangles. And I actually did this in a way, I didn't explain this to you at the beginning here, but I actually did this where I doubled the length of the pink triangle and the blue triangle. That's how I originally set where I was gonna put my angles 3 and angles 4 was twice the distance from one another as angles 1 and angle 2 are. So here, this is just me verifying that I have sides that are in proportion. Look at that. So I had the bottom side is twice the side of the bottom side of the pink one. The right side of the blue one's twice the length of the right side of the red one. The left side of the blue one's twice the size of the left side of the right one. And I've kind of been talking through, but I did this whole process again down here. Oops, we can't see it because my knuckle's in the way. There we go. I did the whole thing down here again, just on a smaller scale, right? A smaller scale. I think I did this one half the size, okay? Half the size here. But I just copied angle 1, angle 2, moved it down there, moved it down there. You'll see my tick marks actually line up if this gets out of the way. And I ended up, right, only took two angles, copying them, right? There's only one triangle I can form, and that triangle will be similar, right? Similar to the original triangle here. That checks out that one. Okay, so just one more example that I did is just to get you more examples in front of you is this is gonna work out with an obtuse triangle. Okay, so what about another triangle? If we copy two angles, must it produce a similar triangle? And let's check it out. I do the same thing. All right, so I did this in the same way where it's like, hey, I actually want to double the lengths here as I do this. Okay, so I swing the arc. Okay, swing the arc. You might have to do this in college, maybe. I don't know. They'll really teach you, but figured I'd show it to you here. Okay, so that's my angle, copy of an angle thing. You're probably like, where did that come from again? I don't know, but I've done this a few times here. Those angles are the same, or they're as close as we can with our tools. Our tools aren't perfect, right? Tools aren't perfect here, okay? Copy that second angle, right? Copy that second angle. It's a pretty cute angle right there. So, you know, I'm going kind of fast. It might not have done perfectly, but those look pretty similar to me. Look, they look pretty similar to me. And right, so all the angles would be congruent because we have copied two congruent angles, and the third angles, right, because we take that away from 180, those would also be congruent too. But if we know two angles of one triangle are congruent to two angles of another triangle, those triangles must be similar to each other. That is the AA postulate that you learned in today's lesson. And there we go, you have it. I remeasured it here. Remember, a compass preserves distance. So I just counted off, right, this length y here on the left side, right, length y here on the left side. If I doubled it, I ended up with 2y on the side. So it actually, if I went twice with that length y, I verified that all three of those sides are twice as large as the original triangle because, yeah, it's similar, okay? So it looks like I wasn't really paying attention here, but it looks like at this point I'm trying to do another triangle, but my camera wasn't actually picking it up. So just take my word for it. Again, just moving two triangles. Ooh, where are we? Wow, I'm writing a whole bunch of stuff down that I guess you guys aren't seeing. Let's see if we can actually see that in the master video. I might have actually cropped this off a little bit here. Okay, so there we go. We got another triangle right down there. Actually, it's a reflection of that one. It's a bit smaller. I didn't try to do it half as much. It just happened to be smaller here. So I had that length. I made it a little bit smaller, but I copied this angle over here and that angle over there. And yes, similar, right? Similar. Two angles of one triangle are congruent to two angles of another triangle. You end up with similar triangles. So side lengths different, right? Different size, but consistent proportion, right? Sides are proportional for similar triangles, and the angles are congruent to one another. Okay, so here we are. You guys are probably done watching this video. You don't want to watch the rest of it. Let's see if I actually, I did cut it off, so you don't get to see what I put down here. Oh, wait, I have my actual sheet of paper down here in case you want to check it out. This is what I wrote. Yes, if two angles in one triangle are congruent to two angles in another triangle, then the triangles must be similar to each other. This is the angle-angle postulate, or the AA similarity postulate. Smiley face, smiley face. I thought that would have looked really cool fast forwarded written out. But anyways, you got me to read it out instead. All right, thank you for watching this here. So just more kind of observations, more kind of demonstrating for you, and maybe just a little bit of talking about constructions, because we're not going to really do these this year, copying angles. But it is something people do to draw shapes accurately and get their feet wet with some of the postulates. And, you know, if you noticed here, I was like, oh, we have to do an SSS triangle construction to do the angles, or to copy the angles. It's everything connects here. All right, email me if you have any questions. This was just kind of a fun video to show you with some demonstrations, but you got your homework problem set. Let me know if you have any questions about those problems. because you're gonna have to use AA similarity postulate and then more practice with similar triangles. How can you get certain lengths, right? Proportions, practicing those. Take care, guys. Bye.